Welcome to Sundar's lecture. This is lecture number 10, and we have what are all the topics we have seen in the last class? We have taken a problem and we have introduced inspection method, which means you see here we have gone for matrix method to solve the electrical network. We know we have already solved these problems by KVL expressions, but I have told you we can solve this problem in a different way. It is not necessary to draw this I1, the current directions in every resistor, and we don't need to write the KVL expressions and all. You just see how many loops are available and you just write down the matrix form, and from the matrix form you get the expressions. Then you simplify this expression or you solve this expression, you will get the unknown parameters. See, it is very simple now. After knowing basic things in electric circuits, we can apply many techniques. All these techniques will give you better insight to the problem. Right? Anyhow, we will see another problem. This is only 2 loops. Let us take 3 loops problem. That is also we have already solved by using KVL in my previous lectures. You can see the lecture. I will give the lecture link in the description, and you watch how to solve this problem using KVL expression also. So, okay. Now we will solve this. See, we have 3 loops here, right? See, we have 3 loops. This is first loop. Anyhow, with the first loop, second loop, third loop will be, it is not necessary or mandatory thing to take this is first loop, this is second loop, or this is third loop. That is up to you. Whichever the loop you want to take it as first, you can take it, no problem, right? Anyhow, so this I am taking, this is my first loop, second loop and third loop. There are 3 loops, 3 closed paths are available. So you just draw the current directions. This is also assumed by us. There is no difference. No, this should not be in this way. It can be in the anti-clockwise direction as well. But we always take clockwise directions only, right? This is I1, this is I2, and this is I3. I am just taking the current directions. Now you see, in this problem, if you want to draw the I1 here, you need to draw I1, and in this resistor, this is I2, and this is resistor, this is I3, and so many current directions has to be drawn. But what we know here, by matrix method, it is not at all necessary to draw anything here. So we know, right? This is R matrix, and this is I matrix will be equal to V matrix. That is what we have seen yesterday. R matrix, how to write the R matrix? Huh? You see how many loops are available? 3 loops. Then what is the dimension of the R matrix? Then it will be 3 cross 3 matrix. That's all. So this will be 3 cross 3 matrix. This is R11, R12. Here it will be R13. If you go here, this is R21, R22, R23, R31, R32, R33. And I have already told you only diagonal elements should be in positive. All off diagonal elements should be negative. That means R12, R13, all these elements will be in negative. This R11, R22, R33 will be in positive. So you put negative in all other elements. Here it is plus minus, here it will be minus, here it will be also minus. So this is the R matrix. And this I matrix, I have told you, it will be a single column matrix, but number of rows depends on the number of loops. Here it is 3 loops, so what you will get? 3 unknown parameters obviously. I1, I2, I3. Simple, right? Simple. It is very simple. Inspection method, solving by matrix method. This is also mesh current analysis method. Whatever we are doing here, it is mesh current analysis method, loop current analysis method R. So what is this V? V also I have told you, it is like I matrix. So what is this? It will be V1, it will be V2, it will be V3, that's all. So now you try to write the expression, try to write the matrix. So this is R11, R11 means what? Total resistance in the loop 1. This is my loop 1, this is the loop 2, this is the loop 3, that's all, right? So loop 1, it is like this. So how many resistance are there? 3 resistance are there. What is the total resistance of these 3? 4 plus 3, 7, 7 plus 1, 8, that's all. So you will get plus 8 here. It has to be plus because diagonal elements will be in positive. Then you go for R12. This is the first loop and this is the second loop. Now you see, while seeing the first loop, you have to take 1 ohms. And while seeing the second loop, you have to take again this 1 ohms, which means this 1 ohms resistor is common to first loop as well as second loop. That is nothing but R12. R12 tells you that it is common resistance between loop 1 and loop 2. Which is that? Which is that resistor? Just 1 ohms. So what you have to do? You have to put minus 1 here. Then R13, you consider this is the first loop and this is the third loop. Now you see here, while seeing first loop, I am getting this 3 ohms resistor. And also while going for the third loop, I am getting again the 3 ohms resistor. Which means this 3 ohms resistor is common to first loop as well as third loop. Which means that is nothing but R13. This 1, 3, 1, 2, 1, 1 are very important to understand. This 1, 3 which is nothing but here it is minus 3. All off diagonal elements should be in minus 3. Only diagonal element should be in positive. Right. Next R21. R21 second loop and first loop. Again here it is this matrix. If you take R12, that will be the R21 because the same resistor or same loop we are going to consider, right? Because this is second loop, this is first loop. Then if you take common resistor, that will be minus 1. That will be 1, so we have to put it as minus 1. Then R22, this is important. You see, this is the second loop. How many resistors are available in the second loop? 2 ohms, 12 ohms and 1 ohm. So 13 plus 2, it will be 14. 14 plus 14, right? Plus 14. Sorry, 15, right? 15, sorry. So this is 14. 12 plus 2, 14. 14 plus 1, 15, right? So this will be 15 ohms. Next, R23. You see, this is second loop. If I am going for second loop, this 12 ohms resistor is coming. And if I go for third loop, there also this 12 ohms resistor will come. So what is this value? This will be minus 12. Then R31. R31 means this is the first loop and this is the third loop. So third loop and first loop, what is the common resistor? 3. That will be R13. R13 and R31 will be same. R12 and R21 will be same. As well as R23 and R32 will be same. Anyhow, so R13 will be minus 3. Next R32. Again, this is third loop and this is second loop, which is the common resistor minus 12, which means this will be minus 12. Same. It will come here also. R33. This will differ because this is the third loop. What is the total resistor in the third loop? How many resistors are available? 3 resistors, and 12 plus 3, 15, 15 plus 2, 17. So 17 ohms, total 17 ohms. That's all. So I1 and I2, I3, I1, I2 and I3 are unknowns if we don't know the values. So we can't put that. So next V1. So we need to find what is V1. So you see current direction is we have taken the current direction in this way. So start from this point and you go like this, come here and come here. Whatever the voltage sources you see, by the current direction you add or subtract the values, right? So go from here, come here. We are traveling from minus to plus, then it will be 24. It will be 24. Then we don't have any voltage sources. So plus 24. If there is a voltage source here, that means plus here, minus here, 10 volt. Then we would have traveled from plus to minus. Then we have to minus that value. So it will be 14 volt, like that. We don't have here, so no problem, right? Next, Next it will be V2, that is second loop voltage. So we have assumed the current direction like this. So start from this point, go here, come here, and you end here, right? So from this point you start, you go, you are going from minus to plus, right? So minus to plus means, which means it will be plus 12 volt, and we don't have any other voltage sources, so it will be plus 12, no problem. So next it is V3. If you take V3, your current direction is like this. So you start from this point, go here, come here, and you have to travel like this. So if I am going like this, I am coming from plus to minus here. So what happens to this value? It will be obviously minus 10 volts. So no other voltage sources are available. So this will be minus 10. That's all. Now what you have to do? You multiply these two terms with first row with this column, with that will be equal to what? 24, and this row multiplied with this column, that will be equal to 12. That is basic matrix. And if you multiply this row with this column, that will be equal to minus 10. That is nothing but basic matrix, right? Multiplying and equating the basic matrix things. So if I write this expression, what I will get? 8I1 minus 1I2 minus 3I3, which is equal to 24, which means you see 8I1 minus 1I2 minus 3I3, which means I have multiplied this row with this, which means if you want to multiply 3 cross 3 with 1 cross 3, then you have to do this way. You have to perform the matrix multiplication like this. If it is equated to some other value like this, then you have to put like this. Right? So this is basic matrix. Try to learn this. So we are applying. So next one, minus 1 I1 plus 15 I2 minus 12 I3 will be equal to 12. Then minus 3 I1 minus 12 I2 plus 17 I3 will be equal to minus 10. You see, this is expression number 1, this is expression number 2, this is expression number 3. And if you solve all these values, what I am getting? I1, and then this is I2, and then this is I3. I will get, right? I have to get 3 values. Let me solve this. So I am getting I1 is equal to, I1 is equal to 4.11, I2 is equal to 2.72, I3 is equal to 2.06. So what is the question asked to us? Find current in the all resistors. So you see, I have found what is I1, I2 and I3. It is very simple to find what is the current in all the resistors, which means this 4 ohms resistor will get this value because this 4 ohms resistor is only connected in the first loop, and 2 ohms resistor will get 2.72 since it is only connected to the second loop, and this 2 ohms resistor is connected only in the third loop, so that it will get 2.06 amperes. But this 12 ohms, this 1 ohms and 3 ohms, you need to apply KCL at this point to get this value, get this current through 1 ohms resistor, and you have to take KVL at this point, KCL, apply KCL at this point to find what is the current in 12 ohms resistor, and you need to apply KCL at this point to get the current in 3 ohms resistor. That we have found already, right? That we have found already. I think in which lecture, I will tell you which lecture we have done it. In this lecture, right? What is this lecture? I think it is second or third lecture. I will give you the lecture link so that you can easily see that lecture. By seeing that lecture, you can easily get what is the current in all the resistors, right? That I don't need to solve. You would have known all these kind of things. This matrix method, we are just using this method to get the simplified expressions. This expression, if you want to write, you can also write KVL, but KVL is very complicated to write, right? Because you need to put so many current directions and so many things has to be done. But if you go for matrix method, it will be very simple to get the expressions. This is nothing but the KVL expressions, right? This is the KVL expression. So this is how you need to solve the problems. Thank you. We will see new topics in the next lecture.